सर चालू हो गया है, ठीक है, वो लाइव हो गया। ठीक है, इसी पे रहिए, है ना।
कैमरा
एक मिनट रुको ना, एक मिनट रुको ना। सौ लोग होने वाला है।
कैमरा बंद कर दी।
रुको ना, लाइव हो गया है ना। मैडम मैं उधर जा रहा हूँ सर के पास, मैं उधर जा रहा हूँ सर के पास, मैं फोन करूँगा स्टार्ट करना।
कितना हो रहा है देख रहे टाइम, 1:26 हो रहा है।
ओके माइक को ऑफ कर दो, यूट्यूब लाइव हो गया है।
माइक ऑफ है।
सर आप लाइव हो गए ये, अब बंद मत करना, ठीक है ना। अब बंद मत करना, ये बात चेक कर लेते हैं, है ना। अब आ जाए, ठीक है, एक बार आप ऑन करो माइक को।
हमारा सब लाइन में इसको कैमरे पे ऐसे लगना है, उधर से कोई कंट्रोल कर रहा है तो बार-बार आ रहा है। कोई भी उधर ज्वाइन हो तो किसी का नहीं। सर आपने ही मोबाइल का देना, मोबाइल ले लो, ज्वाइन कर लो।
हेलो
हेलो अभी बंद किया, अभी नहीं, अभी तो है ना, उससे कनेक्ट कर लो।
हेलो
वहाँ पे आप लोग खाली बैठे हो, टाइम पास कर रहे हो। तेरे लिए ये काम है। रश्मि कैसे दिखेगी? ये वाला किस नाम किस नाम से है रश्मि? इसी जगह
अरे वो जिनका है ना, उस पर क्लिक करो, जिस आईडी से लॉगिन करें। कौन सी आईडी से लॉगिन करिए? अरे उसके नीचे तक आईडी से लॉगिन करिए।
आपने सारे ऐसे बंद कर देना।
लेकिन बाकी कोई आवाज नहीं।
किसकी आईडी लॉगिन किसकी अपनी आईडी की
सर आए क्या? जल्दी को कॉल करना। क्या करूं?
ऐड मत करना है ना, आप ऐड मत करना, लिंक दे देना यूट्यूब पर।
ऐसा ही।
ये वाला ठीक है यूट्यूब।
नहीं ये लाइव
आपका 98 पहुँच गया है सब।
100 से
आपने हाँ अभी
कौन सा नाम क्या?
नाम प्रिंसिपल भी है
प्रिंसिपल भी है। एक मिनट से
दोनों दे
ई में होगा ना,
ERI
नहीं है
ठीक है चल ओके चालू करो चल। क्लोज कर कैसे कर देना सब।
सर के
वो तो अभी दिख रहे तो उसमें चालू करिए बंद कर दिया।
So, good afternoon to one and all present here. It gives me immense pleasure to welcome you all at this international webinar on Smart Grid, the multidisciplinary power system, conducted at Bhilai Institute of Technology, Raipur, and organized under the Department of Electrical and Electronics Engineering. Moving forward with the conduction of our webinar, that is Smart Grid, I would like to edit on that it's today's era. Smart Grid, it is a concept for transforming the electric power grid by using advanced automatic control and communication techniques and other form of information technologies. It integrates innovative tool and technology from generation, transmission, distribution, all the way to consumer appliances and equipments. Now, with much ado, I would like to invite my co-colleague Dr. Khaja Mahaddin to addressing the gathering and enlighten us with the resource person Dr. Hadi Habib Fayaq. Sir, please.
जब बैठने फिर इसको निकाल के ना
A very good afternoon to one and all. First of all, I would like to thank the Department of Electrical as well as Electronics, head of the department, Professor Abhishek Kumar Sahu, the convener of the program, Professor Rashmi Mishra, the co-convener, Professor Jaideep Diwangan, and all the other co-faculty members of the department. A very good event has been initiated by the Department of Tripoli under the guidance of our principal, Sir Dr. T. Ramarao. So herewith we are having one of the renowned researcher among us, Dr. Hadi Habib Fayaq, who has received his PhD degree in 2019 at the age of 29 years in electrical power engineering from Helwan University, Egypt, including associated research with Texas A&M University, USA. He got his BSc degree in 2011 and MSc in 2014 from L1 University. He is the chairman of IEEE Industrial Electronics Society, Egypt chapter. He is currently working as a lecturer as well as a researcher as a faculty of engineering in the energy program in Heliopolis University, Cairo, Egypt. He is working in the research area of renewable energy, power system control, microgrids, optimization, control engineering, and water energy firsts. He has won the grant of study, teaching, and research of renewable energy in Texas A&M University, USA. He is not only as a researcher, but he's also contributed his research in terms of being a reviewer as well as a guest editor of reputed international journals like IEEE, Springer, IIT newsletters, IIT transactions, as well as currently working as the chairman of IEEE Industrial Electronics Society, Egypt chapter. This is a very short brief which I can give from my side. It is very a long way to go to describe a person like Dr. Hadi Habib. A warm welcome, sir, in this event of the webinar. And now I would like to wish and call upon Principal Dr. T. Ramarao, sir, to give the addressing of this webinar. Sir, please.
So, thank you, Dr. Khwaja.
I also request Dr. Habib, sir, to please on the camera so that we can have a live interaction with our principal, sir.
Yeah, Habib. I hope that. Anyway, very good afternoon to all of you, because in India it is afternoon time. So I welcome Dr. Habib from Egypt, a scientist and a researcher who has guided many students in the field of energy. And I also welcome all the participants from India and abroad for this international webinar on smart grid. So this is a very good opportunity for sharing our ideas, sharing our views among all of us, all of the participants here. And this is a great opportunity for all the participants. So we can hear Mr. Hadi, and we can learn from him, from his research. So I congratulate the Department of EEE and the coordinator of this program and head of the department, Professor Abhishek Sahuji, for organizing this webinar. So I am welcoming from the management of Billa Institute of Technology and management of administration of Billa Institute of Technology. So all the participants, and I wish all the participants and the speakers a best of luck. And we are eagerly waiting to listen Mr. Hadi. And so I hand over this mic to Khwaja sir. So please continue, and best wishes to all the participants and the organizer. Thank you.
Thank you so much, sir, for your kind addressing on this webinar. With a warm welcome once again. I welcome on behalf of the IT Rajput family once again, sir, Dr. Hafiz Fayad. I request you to proceed with your presentation slides on the smart grid, that is a multidisciplinary discipline in the area of power system. Sir, please.
Okay, I don't know if you can see my screen or not.
No.
Yes, the screen is visible.
Yes, so now you can see my slides working.
Yeah, done, sir.
Okay, so I would like first to thank you for the organization of this international webinar on smart grids and for inviting me to give this talk. It's my pleasure to present my research to a great university like your university. So thank you for the invitation, and I hope it's beneficial to the researchers and the people who are working in the smart grids or in areas related to the smart grids in a way. Briefly, I'm Hadi Habib. I'm lecturer in the Faculty of Engineering in Heliopolis University for Sustainable Development of Egypt. In addition, I'm the chairman of the IEEE Industrial Electronics Egypt chapter. Well, I would like to start with you the presentation by mentioning what is the idea of the main power system or the conventional power system. Well, we can say that the electrical power system is not something new. The electrical power system is already existing since the 19th century, and its components are central power plant, as you may see, in addition to the step-up transformers to step up the voltage to transmit the power with minimum voltage losses and power losses. And then we have like step-down transformers after transmitting the power from the generation area to the load area to feed the loads at low voltage, which we can say that is 380 voltage for most of the countries who are working in 380 voltage and 220 voltage. Well, so we have generation, transmission, distribution, and then we have the customers and the loads. And day by day, since 19th century, the people who are working in the power system are looking forward to have more reliable, more secure, more efficient, and high quality of supply to serve the societies, especially the industry and the different types of loads. And always the people from the power system are trying to use the communication and the digital revolution to help in improving the performance of the power system. And from this point, we came to the dream of all the people who are working on this sector, in the power sector, to have one day a grid which is fed by more than, I would not say more than 100%, but with at least 100% renewable energy. So you may have the 100% renewable energy and have reserve for the renewable energy in terms of solar energy, wind energy, hydro, biomass, and even the hydrogen generation and storage, and also the thermal storage. But not only that, and to make it more reliable and more secure, you need to monitor how the power is flowing, second by second, or you can say nanosecond by nanosecond. So you need a huge and a strong information system to manage how the power is transferring from different distributed generators and the main power stations, and how the load is changing, as I said, second by second. From this point, then we have two things. We have power flowing and we have data flowing, and this is the main idea of the smart grid. So if you can came to the main features of the smart grid is mainly the modern power system that you through it can monitor and protect and automatically optimize the operation of the interconnected elements of the power system in terms of the generators, the transformers, the loads, and so on. And by the way, this modernization will include all the levels in terms of the generation, transmission, and distribution. And this modernization can be done through installing intelligent devices that will be available, as you said, in the transformers, in the circuit breakers, to optimally close and optimally open at different operation conditions, and also in the electrical household appliances and so on. So from these features and from this idea of the smart grid, so who can work in the smart grid in comparison with who can work in the conventional power system? Normally the conventional power system, and what we well know, that the electrical power engineers are the main contributors of the conventional power systems, also the mechanical power engineers. For the smart grids, the idea is a little bit different. Not only the electrical power engineers and the mechanical power engineers, but we also need communication engineers to transmit the data, computer engineers, because we are already going to optimize, so we need softwares, also the IT engineers. But not only engineers, but people from the chemistry schools and from the physics schools, we need them because we are going to use a new technologies which are based on chemical reactions like fuel cell and the electrolyzers for producing the hydrogen and storing it and then converting it into electricity. Also the photovoltaics and the idea of transforming the sunlight to electricity and so on. But not only that, we also said that the smart grids will include the customer in its process. So the customer is part of the smart grid. He can gain from the smart grid and he can contribute for the improvement of the performance of the smart grid. So at the end of the day, we need to know what is the main advantage of the smart grid, why we are going to the smart grid, why all the world are now moving towards having a smart grid. Well, through smart grid, you can have high penetration level of renewable energy. In order to face the climate change that we are all suffering now, we need to reduce the greenhouse gases and pollution. So you need to integrate as much as renewable energy resources to the grid to decrease the contribution of the conventional power systems, which are mainly thermal ones, and they are contributing to the climate change. So we need to decrease that. This cannot be happen if you are not going to integrate more and more renewable energies. Also, smart grids has many economic benefits for all the stakeholders of the power system operators, even the customer, because through smart grid, through the technologies of the smart grid, you can optimally operate your loads, you can optimally operate the generators and control how much power you can take from each generator in order to decrease the generation cost operation and the power losses. All are very important in terms of the reliability and for the economic operation of the power system. Well, smart grid has also one main advantage, which is the acceleration of integration of the new technologies to the grid. Like what I mentioned, we can easily now integrate the hydrogen to the power grid. However, the hydrogen technology is not that easy, but it now exists. That is hydrogen generators and hydrogen storage systems. And there are many new technologies integrated to the power grid now, tidal power generations, wave power generation, and so on. Also, through smart grid, you can have more efficient operation by optimizing your energy use in your home. So as a customer, you can benefit from this, reducing the peak demand. Normally, in countries which has no idea about the smart grid and the applications of the smart grid, you can find that the peak load is very high in comparison with the average load that is found most of the hours of the day. Through smart grid, you can control the peak demand and reduce it. You can reduce the power losses, which is not useful because you are losing power transmission. Also, as I mentioned, you can manage the load and allow end users to optimize their consumption. So all of this can be happening through integrating the electronic devices to the power system. So if this is the advantages of the smart grid, so what is the problem? Let's have smart grid tomorrow. There are challenges actually, and solution of the challenges is not that easy in the third world countries. Number one of the challenges is that the transition to smart grid is not an easy task. You need capacity building, you need awareness, you need many things. Smart grid means that there is a coordination between all stakeholders in terms of the generation companies, the transmission companies, the distribution companies. As I mentioned, the customers have a big role in the smart grid. Smart grid is not that easy grid. It's a little bit complex because you are integrating many devices, not only power devices. And usually, if you are going to go for the scenario that the electrical power engineers only will work with the smart grid, this will never work because it will be something complex for them. They are not expert in chemical engineering, and they are not that expert even in communication and in the IT and so on. The fourth challenge is that since you are transmitting information and you are taking actions in the operation of the grid through this information, so you have to make sure that this information is correct information. So you need cyber security to avoid hacking and sending false information which may lead to wrong decision, which could be happen automatically, not by a person or by the operator. As I mentioned, it needs high-level training to cope with the idea of the smart grids, the new devices of the smart grid. We need to upgrade the standards to implement the new concepts of the smart grid inside it. Standards of the operation of the renewable energies, the standard of the operation of even the grid codes and the differences between the frequencies, the voltage, the active and the active power, and so on. Needs research and development because smart grid, now there are many applications smart grid, but still something new practically to be applied. Few number of countries who apply smart grids, and mainly the third world countries does not contribute practically well still to the smart grid. And by the way, smart grid is not something which we can end it at a point. No, it's something usually developed by the development of the technology in different perspectives and different fields. So, what are the progress now? What is the world now from smart grid? Well, let us say that the smart grid now is the hottest subject for research in the field of the power system all over the world. And also people from industry are contributing in this research, either through experiment or through pilot project or so on. In Europe and USA, they invest a lot of money towards research and development and even realization of the smart grid. You can say that there are countries which has smart grid and they are smart cities country, which is Colorado in the United States of America, where you can find that they are saving energy through modern digital technologies, and they are trying to operate their grids and their consumption to be from only renewable resources. Smart grid also includes the electric cars and how the charging stations of the electric cars can be used to feed the cars and sometimes feed the grid, because they act as a storage system. And if you require power to cover a need on the power grid side, these charging stations can contribute to this. And also heating and cooling and lighting systems and so on, not only the normal electrical demands. So this is a quick introduction about the smart grid. Let us talk about the applications in terms of research and development that I applied, and many of colleagues that I know and don't know applied it. Well, the most well-known application is the wide area measurement system in smart grid. What is the wide area measurement system? Usually the wide area measurement system consists of 5 components. The phasor measurement units, which are usually used to measure the voltage as a complex number in terms of magnitude and angle. And here the angle represents the frequency. And the phasor data concentrator, where you collect the data got from the phasor measurement units, which to a large extent represents the control center nowadays that's found in every region and in every country. Also the communication network to transfer the information through, as you say, TC, and as we usually do, through routers and so on. And also operator to manage this data. But as much as you move it automatically, as much as you are more successful. And also data storage. Why data storage? Data storage because usually the events are repeated. And what's happened today maybe will be happened next year at the same day or the following day, but next year. So what we did is that we made a study how to make optimal wide area measurement system in area grid, which was the Egyptian grid. We first divided the grid into regions, and then we began to say where to allocate the phasor measurement units in Egypt, achieve the minimum cost, knowing that the phasor measurement unit can measure the voltage of the busbar that is installed in, and for each busbar that is connected to this busbar through a transmission line or a transformer. And then we created all the possible scenarios to allocate the phasor data concentrator or the control center to achieve the minimum cost through optimizing how the communication links will affect us by increasing the budget of the installing of the wide area measurement system, and then we select the minimum cost scenario. It was like 262 million pounds, which is not that much money for a project like this. Well, for the phasor measurement unit, it consists of the GPS, oscillators, and analog to digital converter to convert the analog signals that you received from the grid, which is a measurement of the voltage, to digital, and through microprocessor you can get the angle and the magnitude of this voltage, and we can all share the, all here means all the stakeholders can share this through the modems and the routers and the communication links that we are using. As I mentioned, the phasor is a complex number which usually represents the frequency, and the frequency is the most accurate and the most important part of the grid. Usually, people were trying to estimate the frequency through using SCADA. The problems of SCADA is that it's a point-to-point connection, so you cannot connect SCADA with the SCADA through like Wi-Fi or something. So you need to have something wireless or 5G or 4G or whatever technology to transmit the data quickly. It's used for the real-time energy management system. Usually this data is very useful for real-time control, and real-time means that you take the action in nano or microseconds. Also real-time control, as I said, as real-time protection. There is no delay in the system stage. And this is the optimal wide area measurement system configuration, how we can make it the whole Egyptian grid with the minimum cost. And we found that South Cairo is the optimal place to establish the control center there. And here is the regions of the country. We have 6 regions. The first one includes 3 PMUs, the second one 15, the third is 5, the fourth is 6, the fifth is 11, and the 6th one is 10. Second contribution that we made in the smart grid is to optimally operate the electrical power system. We apply this in standard power systems like IEEE 39 bus system, IEEE 14 bus system, and we applied it to area grid, which is the Egyptian power grid. Usually we have an objective to minimize the power losses or to minimize the generation cost or to maximize the penetration level of renewable energy while operation. And the good news is that we can have two objectives, or even 3 or 4 or 5 can work in the multi-objective. We made a research in how to operate the Egyptian grid with minimum power losses and maximum penetration level of renewable energies. And this optimization process is activated every 15 minutes, because usually the operation of the power grid differs as the I believe mic of someone is open. Thank you. Usually the power grid or operation condition changes second by second, but you can have a time lag between the optimization and the repeating of the optimization and the operation, like 15 minutes or something like this. It depends and it differs from power system to power system. And we subjected our optimization process to the power flow equations and the generation limits in terms of the maximum and minimum active and reactive power, the voltage level constraints, and the thermal limits of the transmission lines, because the transmission line cannot carry more than its capacity for a long time, or we are going to lose it. And through this study, we achieved that through applying this optimization, we can operate the power grid with more than 18% to most of the hours of the day with 100% renewable energy, and also we achieved minimum power losses by more than 15%. But not only the power grid scale, we also applied the smart grid technologies to the microgrid scale. We have 2 projects. The first one is how to feed a marine community in Fiji, Australia, with 100% renewable energy from marine in terms of the tidal system, the offshore wind system, and the wave converter system. This project is applied such that the 3 technologies have the same generation capacity, which is 1 megawatt for each one. And also working in another project on how to operate farms in Africa with 100% solar and biomass energies, and they are interconnected, or we assume that 2 farms of them are interconnected. This research actually, we integrated the goal of the people in energy sector to achieve 100% renewable energy with the goal of the people who are working in agriculture to achieve 100% sustainable agriculture or organic agriculture. We then moved to how to apply real-time control and self-healing in those 2 projects. And we could apply it in the marine while calculating the stochastic nature and the variability of each generation in terms of the wind, the tidal, and the wave system. And we found that the change in frequency is minimal using novel control techniques and the wide area measurement system. In the second project, we applied the same in the solar and biomass, and we used the novel control schemes in terms of the null. And we achieved very low deviation of the frequency. We can say that there is no deviation in the frequency, and this was the aim of this study. So using these controllers, while considering the change in the demand power and the change in the solar power and the availability or not of the biogas, biodiesel, and other biomass technologies. But not only that, I didn't work in the protection, but I know guys who already worked and have many applications in the real-time protection and use the wide area measurement system, which can measure the angle and the magnitude of the sending and receiving. And if there is a fault, you can easily, through equations, after measuring the angle and the magnitude, allocate where is the fault happen, and then you can take the correct action. And through self-healing, you can optimally let the devices automatically take the right decision, either to close or open, which part to close, and so on. But not only that, as I mentioned, Smart Grid, one of its advantages and a feature is that you can integrate new technologies to the power grid in terms of the hydrogen, for example, generation and storage. Well, the idea of the hydrogen is now fashion and many people are working in. Simply the idea is that you through using photovoltaics or wind, which are both of them sustainable power generators, you can through electrolyzer get the hydrogen from the water and you can store it. There are different techniques to store it, either through making it liquid and store it as liquid, or even in the pipes of the natural gas. And then when you need it, you can use it for multi-usage. One of them is through the fuel cell. You can get electrical power and feed the load or feed the grid, or even you can feed the batteries of the electric cars or the electric buses. And this, as I mentioned, these cars or these electric vehicles is part of the smart grid. Also, the smart metering, which I believe most of us heard about it. Usually smart meters help the customer to know what's his consumption in terms of the gas, the electricity, the water, and so on, and how can you automatically control it. And through smart meters, if you have PV system, and now this is something which is not complicated and difficult. There are a lot of photovoltaics companies worldwide in every country in the world, which is installed here the rooftop of many houses. You can sell electricity to the grid, so the customer, through monitoring and controlling the power which is going to the grid, can make actually money, or at least pay less money to the electricity company. And more than that, if you are two farms, as I mentioned, or we have two houses and we are interconnecting with each other, we may try to maximize the benefit together, and why not, and also exchange it with money. So it's now a source for getting money and making business through using the smart meters with the renewable energies like the photovoltaics. Well, this is the references that I used to make this presentation. The first one is targeting the idea of the load frequency control in the two farms in Africa using 100% renewable energy. Second one is targeting how to apply tidal control and the control of the marine community to make the frequency deviation near zero, considering the variation of the power produced from the wave converter, the wind energy turbines, and the tidal turbine or the tidal converters. Also, we applied good results. Actually, there are two papers talking about that. One is conference, and we then make it bigger with more results and more specific studies brought from the Control Center of Egypt to make it more realistic as we can. And also we applied voltage and secondary voltage control, considering a grid only operating from 100% renewable energy. In this research, we converted the IEEE 14 bus system to 100% renewable system, and then we applied secondary voltage control. At the end, I would like to thank you for your attention and your support, for hearing this presentation, and I would like to thank again the organizers for hosting me today. This is my email and this is my phone number for whoever has questions or need illustration, something, and I'm now open for your questions. Thank you very much.
Thank you so much, sir, for your valuable presentation. So I request the participants to kindly raise the queries or your questions regarding the various slides which have been delivered in accordance to the power grid applications or the smart grid applications. I advise the participants to kindly ask the queries now.
Thank you, sir. Thank you, sir. If any participant is having any queries, can unmute yourself or can ask or they can comment it in the chat box also. Any queries from the participants?
Yes, sir, I have one query myself. Let me from my side, sir. Hello. Hello.
Yes. Yes.
The power grid application have been shown in terms of environment oriented or in terms of, you can say, sustainability concept in terms of power grid in environment. How could we approach power grid application based upon the environment reliability?
For the
How could
reliability,
we implement this smart grid?
you mean for the power scale or for the microgrid scale? Or for both?
For both of them.
Look, well, to achieve reliable operation of the power system, so you need to have some strong system for optimally get the right decision. So if you want to do so, you need an expert system, which is usually went through many different operation conditions for the microgrid and for the power grid, and then you train it well so it will take the right decision, which makes the system more reliable. In addition, usually for the 100% sustainable energy systems, you have to originally size it to be much higher, but not that very much, but a little bit higher than what you need. So at all cases, you will have enough power to cover you.
That was nice having the queries from my side, and I hope I also request the participants to kindly ask the queries. Yeah, participants, please.
think somebody is raising his hand.
Hello.
Hey.
So what is the difference between smart grid and green grid?
Hello, sir. Hello. Hello.
Yeah, so one of the participants has the that what is the difference between smart grid and green grid?
Okay. The smart grid is the way to get a green grid because you cannot apply 100% renewable energy grid without employing the smart grid technologies in the power grid. So to reach green grid, you have to use the smart grid technologies. But usually the green grid is the smart grid.
Any more queries from the participants?
Hello. Good afternoon, sir.
Anyone else?
Good afternoon, sir.
After
Sir, myself Abhinav Shukla. I am faculty in BIT Raipur from Department of Electrical and Electronics Engineering. I would like to, sir, ask what kind of influences do we have for IoT when we are talking about smart grid, sir? Actually, I'm working in this field right now, IoT. So therefore, this was my question: that what are the challenges that how we are going to involve IoT with smart grid? For example, like customizable meters and everything. So that was my question: that how we are going to indulge IoT within the smart grid, sir? What can be the challenges and what can be the influences, sir?
Okay, well, the IoT is now already applied in the smart grid. You can simply apply it while operating your house. So a simple IoT system, you can control your demand to avoid having a maximum demand and then paying more money to get the power. So you can use it to achieve the energy saving targets in order to optimally operate each load or each demand that you want to operate
Yeah,
it
yes, sir,
in
yes.
its, yeah.
Yeah, actually, sir,
Uh,
what is going on right now? Whenever we are talking about this power system network, a line loss has been a huge issue, and if there are losses in the line, it added a huge financial loss for the company which is generating, even that is distributing, and those who are erecting transmission lines, towers. So, for example, when we are talking about in local level, how can we, sir, indulge some smart systems so that the line losses can also be controlled? And when we are talking about in any local level right now, IoT is not having some great influences into the local area. Right now, even more research is required. So, sir, what is your point of view in this?
Well, the point of view in this, as I mentioned,
Yes, sir.
to apply the IoT in the power system, which is already part of the smart grid, so you need coordination between the people from the generation and the people from the transmission.
Yes, sir. Yes, sir.
So, yes. So the people of the transmission may install the IoT devices that can monitor and take actions for letting each generator give the optimal power that achieves the minimum power losses for each transmission line, or for the whole transmission lines of the power grid.
Okay. Okay, sir. Thank you so much, sir.
You are
I
welcome.
think no more queries are left over our speaker. Thank you, Dr. Hadi Habib Fayaq sir, for their answer to the queries. Now, before we conclude our webinar, I would like to request Professor Abhishek Kumar Sahu, Head of the Department of Electrical and Electronics Engineering, BIT Raipur, to deliver the vote of thanks. Abhishek sir, please.
Hello, Rashmi ma'am. Am I audible? Good afternoon, one and all present over here. On behalf of Bhila Institute of Technology, Raipur, I, Abhishek Kumar Sahu, Head of Department Electrical and Electronics Engineering, take this opportunity to propose the vote of thanks to those who have directly and indirectly contributed to this webinar on the smart grid, the multidisciplinary power system organized by our institute. At the outset, I thank our chief guest and keynote speaker, Mr. Hadi Habib Fayak. We are really enlightened with your knowledge and presence. We are thankful to our Honorable Principal Sir, Dr. T. Rama Rao, for his motivation. I would like to thank our Dean CNP, Dr. Khwaja Mohiddin, for his enthusiastic support. A special thanks to organizing committee, teaching and non-teaching staff for their unflinching support and coordination. Now, last but not the least, our heartfelt thanks to all the participants for active participation. Thank you very much.
Thank you, Abhishek sir. Now, it was a great session by Dr. Hadi Habib Fayaq. Again, I would like to acknowledge our principal sir, Dr. T. Rama Rao, for helping us to organize this wonderful session. And also to Dr. Khaja Mahaddin, Dean TPU, for his selfless guidance and support. Thank you so much, sir. Also, thanks to wonderful audience for your time and cooperation. I request every one of all that I will be providing the feedback form. Kindly do the needful at the earliest. With this, I, Rashmi Mishra, Assistant Professor of Electrical and Electronics Department, signed off from the today's events. Thank you so much. Thank you, sir.
Participants, the feedback link will be shared in your WhatsApp group as well as your mail ID for the purpose of the certificate of participation. Do wait for the feedback link so that you can get the certificate at the earliest. Thank you all for your participation.
सर कितने बजे तक नहीं अवश्य टाइम
क्योंकि इससे हम बाई मेल भी सबको भेज देंगे। हाँ, मैं तुम्हें भी बैठे बैठे मेल कर देती हूँ ना सभी लोगों को। थैंक यू सो मच अजय सर, शेख सर और सुनील सर, अभिनव सर।
मेल में जाएगा ना।
एक मिनट सर, एक मिनट सर, ये इसमें ये जो है ना मैसेज, ये इस चैट बॉक्स में भी डाल देते हैं, है कि नहीं सर? ये किससे चल रहा है? मेरे में से चल रहा है क्या? मेरे में से चल रहा है ये? मेरे में से चल रहा है ना? मुझे मेल कर दो सर। एक मिनट हो गया क्या जयदीप सर? कहाँ है मेरा जीमेल अकाउंट? व्हाट्सएप कर रहे हो क्या मुझे? व्हाट्सएप भी नहीं है, वेबिनार वाले में हुआ है, इसमें भी नहीं। अब किस में डाले सर? इसमें भी नहीं है। अच्छा अच्छा, नहीं मेरे को ना ये मैं वो कर दिए, मेल कर दिए सर मुझे। जयदीप सर मुझे मेल किए हो?
हाँ मेल कर दिया मैडम।
जयदीप सर इधर आओ, इधर आओ, इधर आओ। वो जो ग्रुप में डाले वो पूरे एक साथ मुझे भेजो ना, मैं एज इट इज फॉरवर्ड करूंगी हर
ये
जगह।
डालो फिर आ जाएगा, कॉपी करो वो आ जाता है। मैं भी ऐसे ही किया था। नहीं यार लिखो, एंटर मार के चला गया।
बता दो।
Please fill the above feedback form. Please fill the above feedback form by today evening.
जी सर। हाँ हाँ मैं भी दे दूँगा दीदी। टुडेज इवनिंग।
फीडबैक फॉर्म एक्सीलेंट तीनों। हाँ तो तेरे को सर्टिफिकेट देंगे नहीं। देख रहे तेरा पर मेरे घर का फॉर्म नहीं है तो मेरा बचा रहा चलो इसको चलो चाय पीते हैं, सहज ये चलो
चलो थैंक यू।
हाँ सर। हाँ